Okay, I just want to do a quick debrief on problem solving problem 1 in our math and logic course. So, remember the problem, this is the one about coat and the cows and the chickens. So some keen observations that I saw you all make. If 25 animals were cows, there'd be 100 legs. Okay. If 25 animals were chickens, there'd be 50 legs. Those two together actually allow for a solution to exist, right? It at least makes it possible because that's between the 66 is between the 100 and the 50. 66 divided by 4 is 16.5, so there must be an odd number of chickens. That's a really clever observation. Okay, the fact that there must be an odd number of chickens because 66 divided by 4 is 16 and a half. Really clever. And one of my students said coat was a freak, which isn't very nice, but that was their observation. Some things I noted, several of you listed the given information, which is what Puglia called those restrictions, above when you started your work. That's really nice because it makes it so you don't have to look back at the original problem as you're doing your work. And there were really two ways these were written. It was either, here's kind of my plan, here's my heuristic, and then here's my work, or here's a bunch of work and then some words to wrap it up. I just thought that was interesting that there was that real dichotomy. For the heuristics and for solving the problem, I saw a lot of systems of equations. Okay, lots of people decided that they knew how to write a system of equations, so they went ahead and wrote those systems so that they could find their answers and then solve them either using substitution or addition. Another way I saw to solve the problem were guess and check. Okay, guess and check was probably the most popular, but it was really close with equations. Okay, where people were just taking different values and playing around with the numbers until they found the pair of numbers that worked. I also had a couple of really nice systems of, or systematic lists or tables. Those are just nice. That's another way to organize. They were really kind of running through guesses, like guess and check, but organized either in Excel or on different lines of the page or whatever. I want to show one more method, and this is the first thing I think of whenever I see a problem like this where the numbers are small enough. Now, I don't normally do what I'm going to do or what I'm going to show you, but it's what I think of. So to do what I'm going to do is I'm going to use manipulatives to represent the cows and the chickens. So I got some paper and I've got some toothpicks. I cut out that paper into 25 rectangle-ish shapes. And then I took 66 paper clips. One of the guys is hiding underneath where I am here. But I've got those animals over here. These are either cows or chickens. I don't know which. And then I've got my 66 paper clip or toothpicks. I started by taking a pair of toothpicks and putting them on each animal. Okay, each animal has at least 2 legs, so every animal needs at least 2 toothpicks on it. That left me with 16 leftover toothpicks. If I then take those 16 toothpicks and put them onto the animal so that some of them have 4 legs, you can see I end up here with 8 animals with 4 legs, so cows, and then 17 animals with 2 legs, so chickens. So this is one way to use manipulatives to solve this problem. And like I said, this is what I think of when I have a problem like this that's small enough I can picture it in my head. So if I was presented this problem just on the street, I'd be like, okay, 25 animals, that's going to take up 50 of the legs. That'll leave me 16 legs left over. Every cow has 2 more legs. 16 divided by 2 is 8. There's 8 cows and then 17 chickens. So that's kind of the mental version of laying out the pieces. Just some notes. Okay, so some of you just didn't have enough work for me to know what you did. Some of you said, C plus K is 25, 4C plus 4K or 2K is 66, and then you just went to the answer. Okay, there are a bunch of ways you could have solved that. You could have used a Google calculator or any online calculator. You could have solved the system using, one of those methods. You could have used guess and check. I just want you to tell me what you did. I don't care how you solve it, right? All of those are totally fine ways to do it, but I needed you to tell me what you did. Okay, what about the difference between guess and check and trial and error? Okay, so remember, trial and error, the situation tells you if you were correct or not. So that's like trying to find the correct wrench to use on a bolt or a nut. Guess and check, you check yourself. Okay, so since 8 plus 17 is 25, and 8 times 4 plus 17 times 2 is 66, then 8 and 17 could be my answers. Okay, so trial and error, the situation tells you. Guess and check, you're deciding if you're right. Think for a second, is this enough work? So if x is cows and y is chickens, I've got x plus y equals 25, 4x plus 2y equals 66, so 2x equals 16, and code has 8 cows and 17 chickens. I'm going to guess some of you out there are saying, no, that's not enough work. I need to tell you, for me, that is enough work. Okay, that's totally enough work for me to understand what I did, see it at a glance. I'm like, oh, I wrote a system of equations, perfect. I assume I solved it by using the addition method, which is how I solve all my systems of equations if I can. And that gets me to my answer. Now, some of you need more than this because you haven't solved systems of equations. Some of you need to write out more of your guesses so you can see, oh, okay, so that's what I was trying to do. I had too many cows here, so I went down and had less cows so that I could have more chickens, and that got me closer to the answer. You need to write enough work so that you understand what you did and how you got your solution by just glancing at it. Okay, that's our goal. Because if we can do that, if we can glance at our solution and be like, I got it, I know what I did, we can use that method on future problems. So some of you didn't write enough work. Okay, some of you need to flesh it out a little bit more so you can remember your solution for the future. And some of you wrote too much. Some of you are really familiar with systems of equations, and so you wrote out every single step, which is great for a math class, but it's not great for reasoning because you didn't need to write out every one of those steps. Okay, so just something to think about. I want you to write enough work and do enough work so that you know what you did. Finally, just some notes on presenting your answer. Okay, when we solve problems, other people almost always only care about the answer. We want to make it clear and easy to find. So first, avoid too many numbers or too much extra information in your answer. Okay, so I wrote code who has a funny name, has 17 chickens, which is a total of 34 chicken wings / legs, and 25 minus 17 equals 8 cows with 4 times 8 equals 32 legs, and 16 horns if they're cows that grow horns because 7 plus 8 equals 25. That's too much, okay? People want to see your answer, instantaneously. When they glance over your work, their eye should be caught by your answer, and they should be able to tell what your answer is right away. Okay, we also want to make sure we label our answers, right? So if I'm looking at your paper and I want to see what is your answer, and I see C equals 8 and K equals 17, I can usually look through your work and be like, okay, yep, C was cows and K was chickens this time. But it doesn't help someone who didn't ask you anything about C and K. Okay, when we give our answers to people, we want to make them clear. We want to make sure they know what they're looking at. Finally, you want to make sure people can find your answer. I'm bad at this. Those of you that read my feedback, you know I ramble a little bit. I get on a tangent or I say something that doesn't quite link up. Don't hide your answer in here. Okay, have it be on its own. Have it be its own statement that's just, here's the answer. So for example, in this problem, if you had written a complete sentence with just the necessary information and had that sentence after everything else, that would have been a fine way to draw attention to your solution here. Code has 8 cows and 17 chickens. Okay, clear. No extra information. It's not hidden. It's just there. Okay, looking back isn't required for problem-solving problem assignments, but certainly it's something that you can do. So if you take a minute and think about those things that Puya has us think through. Can we check our solution? Can we check our answer? Can we look through our solution and understand each step? Have we learned anything? Could we use this solution on new problems? Okay, think about those things. Of course, if you have anything to share, since we're not in the classroom, you could throw them in the comments if you wanted. For my in-person students, for sure, I'll be yelling at them and making them tell me something that they've learned or something that they observed. But that's it for our first problem-solving problem. As always, if you have any questions, just let me know. Thanks, everyone.